eli5 What does it mean when they say folding a piece of paper 42 times will reach the moon? The folding is perhaps a distraction. When you fold a piece of paper, it arguably gets twice as tall, because you stack half of it on top of itself. The width of the paper doesn't matter, just its height, so we can replace fold with double the number of sheets of paper in the pile and the height should be the same. So, if you take one sheet of paper, and then double the height of the stack of papers 42 times, that is what allegedly reaches the moon. 42 doublings is a huge amount, so I wouldn't be surprised if this were accurate. Normally we like to think of a single sheet of paper as having zero thickness, and it's close to zero, but it's not exactly zero. It's something like 0.05 millimeters. When you fold a sheet of paper one time, you double the thickness, i.e. 1x. This generalizes to when you fold the same sheet of paper n times, the result is something that is 2n as thick. So the math is simple, it's 2n x 0.05. Assuming that the 42 times calculation is correct, that means 242 by 0.05 is enough of a distance to reach the moon. It's all math, proof. It's the same reason why we can measure many things that happen beyond our imagination, like how a black hole works or what happens if certain things approach light speed. Math lets us go where our imagination can't. In that regard, the paper theory is a scenario of how thick it could get if someone was physically capable of folding paper beyond what we humanly could. Granted, the thickness would be infinitely small by the time we reach the observable universe part. It means, never underestimate the power of exponential growth. Ever heard a story of a smart-ass chess player that beat the king at chess, and offered anything he'd want? He said that he only wants as much grain as can be put on a chessboard, with every next field doubling the amount of the grains? Seems small, stupid? It's 264 in total. Several years of Earth's crops. Not only he was good at chess, he was also smart with math. An example you can more easily try for yourself is the rice on a chessboard. Put a rice corn on the first field. Double what's on the first field for the second. And so on. Just thinking about it, you don't think it's that much rice. Trying to do it, you will soon run out of rice. Calculating it to the 64th field, you will realize that more rice than atoms in the world or something like that. Exponentials. 2 is 4. 8 is 256. 16 is 65,536. 32 is 4,294,967,296. 242 is 4,398,046,511,104. Multiply that by 1 millimeter, and that's 2,732,819.4 miles. Now, you can't really fold paper that many times. There's not enough mass, nor could the material be bent stretches to that extent. I believe the limit is 7 folds. This is more so a hypothetical double the width of a piece of paper 42 times. Instead of folding, imagine cutting. You take an A4 piece of paper. Cut it in half. Stack the two halves on top of one another. Now take that stack and cut it in half and stack again. 4 pieces of paper 2 by 2 or 2 2. Again. 8 2 by 2 by 2 or 2 3 16 2 4 32 2 5 etc. until you do that 42 times 242. Multiply that number by the thickness of a single piece of paper. And boom! Moon! Would you rather have $1 million right now? Or 1 cent today, 2 cents tomorrow, 4 cents the next day, 8 cents the day after, and so on, for 30 days? While most people would think $1 million right now, actually doubling a penny every day would net you more than $10 million in that first month. Doubling results in an incredibly rapid growth rate. Basically, each time you are folding the piece of paper, you are going to be doubling it by its current width. It might take 10-25 doublings for it to get to a width that starts to make a difference, but very quickly after that it will explode in size hypothetically, and further double itself until it reaches the moon. It just means that 242 is a very big number. It's a way to try and illustrate that visually. The thickness of an average piece of paper is pretty small, 0.1 millimeters. But that very small number multiplied times a ridiculously huge number 242 ends up being a very big distance, 240 miles. It's impossible to actually fold a piece of paper that many times, you wouldn't even get to 10 most likely. This is because every fold is doubling the thickness. So 1 fold is thickness x2. 2 folds is thickness x2 by 2. 42 folds is thickness x242. 242 is 4,398,046,511,104 sheets of paper. If you fold a piece of paper, you are doubling its thickness each time. Say an average piece of paper is 0.1 mm thick. To calculate the thickness of the paper after 42 folds, you have to do 0.1 by 242, which after conversions works out at 440,000 kilometers, which is longer than the distance to the moon. When you fold a piece of paper that's xm thick, you get a piece that is 2xm thick. When you fold it again, you get a piece that's 4xm thick. Do that again and you get a 8xm thick piece. Fold the paper 42 times and you get a piece that's 4,398,046,511,104 xm thick. As others have said, exponential doubling. Here's a cool example of why it can't happen. Mythbusters tried to bust the myth that you can't fold a paper more than 7 times. NTGs, question: how big would a piece of paper have to be to manage the 42 folds to make it to the moon? Solar system sized? Galaxy sized? Universe sized? Or is it simply not possible to get to 42 folds anyway due to dimension problems after X number of folds? The important part is that you are folding it in half every time. You can put 42 folds in a single sheet of paper, no problem, but folding it in half means the number of sheets is doubled. Without that stipulation, the number of folds is meaningless. Think of each time you are doubling the thickness of the paper. Jump on a calculator and take a simple number like 1 and double it 42 times. That number gets pretty big pretty quick. If you are strong enough to fold a piece of paper in half 42 times, you can walk into NASA headquarters and force them to put you on the next rocket to the moon. You're doubling the thickness of the paper wide with each fold. Start at like 1 mm guesstimate and multiply it by 242. That's essentially what they're saying. Because you can't fold 1 past 7, and if you can find something that can create that much energy, we can harness it as an engine fuel source to run a rocket. 242 power 4.4 trillion. So take a piece of paper 0.009 centimeters, 4.4 trillion 395,000 kilometers, which is more than the distance to the moon, 384,400 kilometers. Mythbusters talk about this in TGs. Each fold doubles the amount of paper in a stack,